Hi, my name is Nathan Strout. I am the Technology Manager for the Redlands Institute at the University of Redlands, and I would like to take a few minutes to show you a website that we created with the Lower Colorado River Regional Water Quality Control Board in the Imperial Valley of Southern California, known as the Imperial Valley Spatial Data Infrastructure, or IVSDI project. The goal of the project was to support the regional board's implementation of the sedimentation total maximum daily load, also known as a TMDL, in the Salton Sea watershed, and provide the regional board, growers, and other stakeholders in the region with easy access to the information they need to monitor progress, analyze problems, and design solutions for the reduction of sediment runoff and the eventual drainage into the Salton Sea. There are several pages on the site with general information about the Imperial Valley and agriculture and water quality within the valley. This video will specifically be looking at the mapping and reporting pages, which can be accessed through the tab at the top, the Maps and Reports tab here, or the Map Tools link on the home page. Now, a quick note about the technology of the site. The site and web services were developed with ESRI's ArcGIS server technology and their JavaScript API. On the Maps and Reports page, we can see a map zoomed into the Imperial Valley. The map allows for your standard pan and zoom navigation using the mouse or the scroll wheel, as well as the buttons here on the left. We've got two separate map views, the satellite or aerial view, which we're looking at now, or a map view, which has the streets and physical features. We can turn on and off different layers using the layer settings dialog. We can turn on the labels here. You can see all the canal and drain labels load. We also have a dynamic legend which can be collapsed or expanded to get some description of what the different features are on the map. And you'll notice that as we zoom in, we get more and more detail on this water network. We can also search for street addresses or gate numbers, which are the water delivery address for a plot. And by doing this, we can zoom directly to that gate or street address. Another feature you've no doubt noticed are these monitoring stations. These are locations that agencies regularly sample and report on water quality so that trends can be analyzed over time for that location. The locations for these points are actually being drawn by querying a massive repository for water quality known as STOREit, which is maintained by the US EPA and allows water resource management groups to publish their water quality monitoring data, as well as allow users to access and query the published data like we're doing here. It's important to note that this is a national program, so we're not restricted to the Imperial Valley region for water quality data. And the last features I'd like to look at are the drain sheds. Drain sheds are a management unit used by the regional board and can be described as the collection of farm plots that all drain to one of the 10 monitoring stations regularly monitored by the regional board. This allows the regional board to attribute the water quality results of the station to agricultural practices or perhaps a particular event that may have resulted in a significant change to the water quality readings within the drain shed. We've also added a way to quickly jump between the drain sheds. So now let's take a quick look at the reporting tools. The first one we'll look at is the water quality report. And you can generate one of these by clicking the water quality report up in the right. And we can select which stations we want to report on by either clicking on them in the list here or by actually clicking on the monitoring station on the map. And we'll select a date range here, and I will select the default, which is a 10-year range, and click OK. The site is now searching both the EPA STOREit data warehouse as well as water quality data that the regional board collects that is not currently published to STOREit. We can see that at the top we have the date range that we selected and the two stations along with a map. And we also have a list of the constituents that are measured at these two stations. And you can see that there's a lot of them here, and what these checkboxes are denoting is whether or not that constituent is measured at that station. So you can see perchlorate here at the bottom is measured at one station but not at the other. Now this list is meant to be a control to select which constituents you would like to look at more information on. We'll go ahead and look at the total suspended solids, or TSS, constituent, and the water temperature results. Now this is generating a table and a graph at the bottom. TSS is of particular interest for this project because this is the metric used by the TMDL program to monitor progress. So you can see that you have a table with the minimum, average, and maximum results returned for each station for this constituent of TSS, and we have a graph that shows the trend over time. We can actually hover over any one of these points and see the exact reading and the date that that reading was taken. We also have a line drawn on the graph to show the average, and for TSS we have a line to show the TMDL target of 200 milligrams per liter. Now you can see clearly that there are several values of TSS over the TMDL target, and in fact the TMDL and average are almost identical. So scroll down, we can see because we added water temperature to our report, we have another table and graph shown at the bottom. And again, we have the minimum, average, and maximum values and the graph to show the trend. You can see a very clear trend and correlation between these two monitoring stations. The next report we're going to look at is the agricultural practice report. These reports aggregate information that individual growers in the region provide as part of the TMDL voluntary compliance program, which asks growers to provide some general information about their growing practices, such as the types of crops they grow, any non-point source pollution problems, site conditions, and very importantly, which of a list of 24 identified best management practices, or BMPs, they are or plan to implement. The site aggregates this information to the drain shed for obvious privacy concerns. To generate an agricultural practice report, we must first select which drain sheds we'd like to report on, and then select a reporting year to report on. And go ahead and hit OK. And you can see that the report is formatted very similarly to the water quality report in that we get the date range and the drain sheds along with a map of where those drain sheds are. And the first thing that we see on the report is a graph of the number of growers that have implemented or plan to implement each of the best management practices, or BMPs. You also see a graph of the top 5 BMPs being implemented. The names of the BMPs were too long to show on the graphs, so we used a number that you can refer to the table below to find the full name of the BMP. This table also shows how many growers in each drain shed are implementing or plan to implement those BMPs. We've also added links to more information about these BMPs, which come from the Imperial County Farm Bureau's website. The next piece of the agricultural practice report are the site conditions that growers have reported. And again, we have the graph and a table. The non-point source pollution issues that the growers have identified. And lastly, we have the crop types that the growers have reported. So that's all I wanted to show you today. So hopefully you got a better understanding of what you can do with the site and a little bit about how it works. So thanks for watching, and for more information you can visit the website at www.spatial.redlands.edu/IVSDI.